I'm super excited for this one. This is Air Filter 101, everything about air filters, how they work, what we're trying to do with air filters. And then part two, we're going to look at a bunch of different popular models and show you which ones you probably want to get and which ones you probably want to avoid. So before we get into how to clean the air, we got to talk about why to clean the air and what's in the air. So air has a mix of gas and particles. The gases are things like oxygen, nitrogen, CO2. Particles can be things like viruses, allergens, dust, tiny specks of metal, soot from wildfire smoke, all kinds of things like that that are not good for us to breathe in general. Now, our bodies have some ways to deal with this. For example, our nose has nose hair and mucus and various things that try to filter things out. But these smaller things, PM10, PM2.5, things like little particles from combustion, pollution from cars, pollen, mold, various things can get through our defenses and go into our lungs, into our body, not good for us. And airborne viruses like COVID tend to be in around the PM2.5 area. So when we want to know how good an air filter is, there are three things we're looking at. One is the clean air delivery rate. How much clean air can this thing pump out? The second thing is noise, and the third thing obviously is cost. So we need to break down clean air delivery rate to really make sure we understand it and how to use it. Clean air delivery rate is usually measured in cubic feet per minute, or cubic meters per hour. So what does that mean? This bin is about 1 cubic foot. It's about 1 foot by 1 foot by 1 foot. And there's air in here. So an air cleaner that cleaned 1 cubic foot per minute could clean all the air in this bin in a minute. Now the room I'm sitting in is about 12 feet by 20 feet by 9 feet, which is 2,160 cubic feet. So if my air cleaner can only clean 1 cubic feet per minute, it would take 2,000 minutes to clear this room, which is 36 hours to clean the room once. That's probably not good enough. Now, luckily, air cleaners can clean much more than that. The ones we're going to be talking about in the next video are probably around 100 cubic feet per minute, maybe 200, 300. So a 200 cubic feet per minute air cleaner, which is very achievable, not super, super expensive, that would be able to clean 2,000 square feet in about 10 minutes. So that would give us one air change. It means all the air in the room is being cleaned once. If you can clean all the air in the room once, great. What if someone is continuously breathing virus or you have new allergens coming in from outside? We need to be continuously cleaning the air. In public health terms, a good target is 5 to 6 air changes per hour, so that every 10 or 12 minutes, any particles in the room have been cleaned out. And when new particles enter, they'll be cleaned out over the next 10 to 12 minutes. So clean air delivery rate is a measurement of how much air passes through a filter and how well that filter cleans the air. And I think it's important for us to understand how it works because there's so much misinformation out here. I think it's important for us to understand how filters work so that we use them effectively and can tell other people how and why they work. Now, some sources for how filters work. One would be this awesome t-shirt by Amanda Hu. I'm not sure if you can buy them, but check out Amanda's stuff. Awesome. But also another article that Amanda shared to explain this t-shirt is an article about masks because N95 respirators and some of the filters we're talking about work very similarly. But I think one of the best breakdowns is an article by Jim Rosenthal from July 2020, Understanding How HEPA Air Filters Remove COVID-19 from the Air. Air filters and masks can use 5 different properties to filter particles. The first mechanism is straining, where a particle is just too big to pass between fibers in a mask or a filter. It just gets stuck in between them. And that's the most obvious one, but it only captures about 1% of particles that way. The other methods are actually much more helpful. So when people say, for example, COVID is too small to be caught by a mask, they're thinking about straining. They're thinking about there's fibers and a particle can get between the fibers. That's a very small picture part of what we're talking about. The second mechanism is basically running into things. With impaction or impingement, the particle literally runs straight into the fiber. Now that also only accounts for about 1% of the filtration. The third mechanism is interception, and this is where we start to get 30 to 40% of filtration coming from this kind of activity. There's something called van der Waals forces. This is where something starts to brush past the fiber and kind of get snagged by it. You could almost think about it like friction, although technically it's not exactly the same thing, but that's sort of what happens. It brushes against the fiber and gets kind of stuck to it. The fourth mechanism is diffusion, and this is a property of very tiny particles. They don't pass in a straight line. They move very unpredictably. They're getting buffeted around by your breath, by air pressure, currents in the air. For example, people use is, you can run through trees in a forest. You are small enough to get through those trees. If you close your eyes, you're probably going to hit a tree. That's a good metaphor for diffusion. And diffusion is also called Brownian motion if you want to read more about this. Now, the fifth method is electric charge. This is huge in N95s and respirator masks. The mask has a charge imbued into it, and viruses have small charges in their structure. So it's sort of like a magnet. Things that have electric charge can pull in viruses like a magnet. HEPA filters don't use this generally because they're just purely relying on these other more mechanical things we just covered. But respirators and MERV13 filters that we're going to talk about, they do use this magnetic electric charge. So quick review. Straining is when a particle can't fit between the fibers. Impaction, when a particle hits the fiber directly. Interception, when it brushes against it and van der Waals force makes it cling. Diffusion, when the particle is moving around in a wild pattern and hits the fiber. And then electrostatic attraction, where it's pulled in like a magnet. Because of all these different mechanisms, filters and masks are actually really good at getting rid of tiny particles and really good at big particles. It's sort of this small medium that is the hardest for them, and this is what an N95 should get 95% of the particles in this area. So we said that clean air delivery rate is how much air passes through and what percent of that air is cleaned, using those mechanisms we just outlined. So then the question is, what kind of filter do we need? HEPA filters filter 99.7% of particles that pass through the filter. And that's great, but we don't actually need it to be that good. While HEPA filters might be able to filter out 99% of particles that pass through, MERV13, MERV11, furnace filters, they can filter 60 to 70% of infectious virus every time air passes through the filter. But if you can get a lot more air through that filter, the MERV 11 or 13 is actually better, and let me just show you with a very simple equation. Let's say with the HEPA, you can pass 100 cubic feet of air through it per minute, and it filters out 99.7%. Great. You now have a volume of clean air of 99.7 cubic feet. Now with the MERV 13, if you can pass 150 cubic feet of air through per minute, and you filter with 75% efficiency, you end up with 112.5 cubic feet of clean air. You just got more clean air with less filtration effectiveness. So the point of all that is that as long as you know the clean air delivery rate, you don't really need to worry about which filter it's using as long as you're going through a legitimate supplier. Ultimately, you just care how much clean air is coming out of this thing. In the next video, we're going to break down looking at various air filters and what their clean air delivery rate is, how noisy they are, and what their cost is to try and pick some good air filters. If you want to learn more about air filters, I recommend you going to itsairborne.com. Joey Fox is a great resource where I got a lot of information for this video.